Hey there! In this video, I'll share with you an effective way to use energy profile diagrams to illustrate an exothermic process. I'm Orlando Broomfield from Chemistry Core. Let's solve this chemistry exam style question together. Let's use this energy profile diagram to illustrate an exothermic process where the y-axis shows energy increasing, the x-axis shows reaction progress, and the reaction taking place is between the reactants AB and CD, which are forming the products AD and CB. Now, every chemical will have energy within them, and that energy content of chemicals is known as enthalpy. But for reactants to be changed into products, energy needs to be supplied. This energy supplied will cause the bonds in the reactants to break so that new bonds can be formed in the products. So, as the reactants absorb energy, they need to do so until they reach a certain amount of energy that will cause the bonds to be broken. The minimum amount of energy required by reactants for bonds to be broken is called the activation energy, and it can be represented by the letter E and a subscript A. This energy of activation will come into effect once the reactant particles are in an intermediate state of instability. Then the bonds will break. When the bonds break, new bonds will be formed, and during that process of formation of bonds to make the products, energy is released. And so, as we can see here in our energy profile diagram, the energy level will come down until we reach the level of the enthalpy of the products. There are two things here that indicate that this energy profile diagram is for an exothermic reaction, and these are: one, the energy of the reactants is greater than the energy of the products, and secondly, the energy released during bond formation for the products is greater than the activation energy. Let us represent the activation energy on the diagram. So it will be between the highest point reached when the reactants absorb energy for their bonds to be broken, and the starting point, that is the energy of the reactants initially. The difference between the energy of the reactants and the energy of the products is called the enthalpy change for the reaction. And that is given by a negative sign, which represents an exothermic reaction, the Greek letter delta, which represents change, and the letter H, which represents enthalpy. So, this is the third indication that we are drawing an energy profile diagram for an exothermic reaction, and that is the negative delta H symbol. Now, if we were to add a catalyst to speed up the rate of this reaction, this is exactly how the catalyst would work. It would lower the activation energy, which is the minimum amount of energy required for the reactants to absorb so that they can have their bonds broken so new bonds can be formed. And this new activation energy is a direct result of the catalyst doing something special. So let's indicate our activation energy with catalyst. And that special thing that the catalyst is doing is creating a new pathway for the reaction to occur, and that new pathway has a lower activation energy. So more of the reactant particles will be able to attain that minimum amount of energy required for their bonds to be broken so that new bonds can be formed. Thank you for watching another video on solving problems in chemistry with Chemistry Core. If you were tuned in, you are now able to use an energy profile diagram to illustrate the differences in the enthalpy of reactants and products, and activation energy and the energy released, as well as how a catalyst speeds up the rate of an exothermic reaction. Good luck on your exams, and I'll see you next time.